And so now I invite the panelists in the next section. How do we measure circularity in aquaculture? So we've first set now the sustainability context, and the next step logically is to put it into practice. So Inma Sanchez is the first speaker today in this session, circularity expert at Lightot in Barcelona. And she's going to present indicators and methodologies developed in the iFishIENCi project. So Inma's been collaborating with companies and governments in Latin America to implement environmental projects regarding waste management and sustainability indicators, also international certifications. So Inma is in both Horizon 2020 Research and Innovation Action projects, iFishIENCi and Impact, in developing circularity analyses. So Inma, welcome to the screen, and the floor is yours.
Thank you, Dorothy. I'm going to share my screen. Yes. Okay. Can you see?
Great.
Okay. So good morning, everyone. It's a real pleasure for me to be here today, and of course to be part of the team that works on those projects. I'm going to present about the case of iFishIENCi project, and particularly I'm going to introduce the topic of indicators and methodology for circularity assessment. First of all, it may be of interest to remember the concept of circular economy before starting, although most of you are already familiar with this definition. But a circular economy is a model of production that put the focus on the reduction of waste and the extension of life cycle of products. But also we need to ensure that we are creating further value within these value chains. And like other management strategies, in my opinion, circular economy should be measurable. So in this sense, the European Commission is monitoring the circular economy through the Initiative for Circular Economy Monitoring Framework. This framework provides us 10 different indicators to monitor circular action in production and consumption, waste management, secondary raw materials, competitiveness, and innovation. Some of these indicators have been defined by Europe, by the Joint Research Center, and the other one has been defined by the Euro. Particularly patents indicators has been defined by European Patent Office. And you can check the monitoring on this circular action directly on the Eurostat website. This is an example to monitor or to measure circularity in micro level. But what happened in micro level at industrial level? And the thing is that there is a lack of industry-specific indicators to measure circularity. And there's no common way of measuring circularity in this level. So that's why we are starting to work on iFishIENCi to do that. But before introducing the project, I would like to share this the chart on the right side of the slide. This is a summary of the most common indicators provided by literature regarding the circularity assessment, and most of them are referring to our framework, that is indicators for measuring recycling, reusing, remanufacturing, and so on. And yeah, in that point, it's interesting to speak about the iFishIENCi project. iFishIENCi is a project that started in 2018, and we will be finishing next year. We are 16 partners from Malta, Norway, Spain, France, Germany, Denmark, Greece, Hungary. And we are working together to provide to European aquaculture sector with an innovation that can support sustainable aquaculture based on enabling technologies, but also thinking in circular principles. We are working in 3 different pillars. First of all, is the pillar about feeding and monitoring technologies. The 3 objectives of the project here is basically focused on the technological development. We are working to provide several tools for the industry. For example, Fish to Talk to Me is a tool that provides information on fish and biological parameters. But also the people from the project experts on technology will provide a solution through the integration of platform for testing and quantifying, demonstrating the feed and the feeding systems and that kind of things. The second pillar is the pillar connected with the circular principle, as it is the focus is to develop or to provide new feeds, sustainable feeds to the industry, and sustainable breeding strategies. Thinking about the circularity when we are feeding and when we are developing new feed formulas. And finally, we say in iFishIENCi project, we say that we are working for the sustainability of the sector as we are integrating also the social dimension in the project. This is the third pillar. We are working with Dorothy, who is the leader for that. We are working on innovative research and responsible innovation platform. We are developing strategies to engage stakeholders, policy makers, consumers, aquaculture industrial sector. And also we are working on some kind of training activities. So we are integrating the social dimension as part of the sustainability in the project. We are organized in seven different work packages. Sustainability and circularity is one of the core work packages in the project, as we are providing information to different work packages, and we are using the outputs from the demo sites and the results from operational environments. But where is the circular concept in iFishIENCi? Basically, we are suggesting we are moving from the linear model to a circular one. In the linear model, we can see that we produce fish, we use natural resources, basically feed, and we are generating waste. Sometimes this waste is not recovered, and this is absolutely linear. And in iFishIENCi project, we are suggesting to move to a circular way, our circular production, where we can integrate algae as a new or innovative feed ingredients that can be grown with waste from RAS system. So we are working with the RAS concept, which is obviously a sustainable way of production, where we are recirculating waste and water in the site, and we are using the sludge and the water as substrate for algae cultivation, but also the algae is using residual carbon from the industry, so it's totally circular. Finally, this feed can be used for feeding the RAS system again. And in that point, we started the project and we thought, okay, what to measure? Well, we needed to measure how well the proposed aquaculture value chain performed in the context of circular economy. But also we needed to know how restorative the RAS system and materials flows are. And how to do that, how to measure is is a real challenge. But basically we need to quantify firstly the inputs coming from virgin and recycling materials or reused components. Also quantifying the materials that cannot be recovered and go to landfill. And also quantifying components collected for reuse. But also the efficiency of the recycling processes is a key issue, as we need to ensure that the efficiency is high in the recycling process. And to do so, we starting to think about the circularity of the feed. The feed formulas and the feeding ingredients is a core issue in the project. And to do so, we focus first of all in the Helen MacArthur indicator. That is an initiative developed in 2015. It's quite nice because it's based on a life cycle thinking and it's focused on product materials and components. But on the other hand, this methodology doesn't provide us a methodology for biological cycles. It's only developed for technological cycles. And technological cycles, I mean, for example, aluminum manufacturing, steel manufacturing, and so on. So we needed to adapt. First of all, we needed to adapt the methodology to biological processes in iFishIENCi. And to do so, we identify main parameters to consider. First of all, virgin materials use in the feed production, efficiency of the recycling processes, generation of waste, and fraction and efficiency of the valorization routes. And also focusing on the feed, we identify that the circularity assessment should consider the portion of raw materials that is included in the feed, the restorative materials flows that comes from reuse of recycled sources, and the concept of utility is quite relevant. This aspect, as if we provide a circular feed, but it's not usable or it's not real easy to digest by feed, we will not have a commercial feed in the end, or we won't have a feed with utility. So based on these three objectives, we defined the linear flow index in line with the methodology from Helen MacArthur. We also defined the circularity for materials, and at that point we included the assimilation efficiency as an utility parameter, and the nutrient waste generated. And this is for the assessment of the circularity of the feed. But also we started to think about what happened with the process. I mean, if we don't use the feed for the industry, or if we extract algae components to other industries, this is also some circular in some way. Although we are generating raw materials for other industries, not necessarily for aquaculture. So to consider this in the project, we also integrate a zero waste indicator that basically gives us information about the capability of the industry to recover resources from waste and to generate valuable inputs for other industries. So we are assessing the circularity on the feed and assessing the circularity on the process. So coming a step, as I mentioned before, we will be finishing the project next year. So the first step now is to validate the methodology. And to do so, we will be collecting data from the demo sites and the trials. We are particularly focused on the trials for feeding and waste valorization experiments. And we will be interpreting the results from these demo sites and trials. And hopefully we will be providing recommendations for the industry in terms of circularity assessment at the end of the project. And I think that's on from my side.
Thank you so much, Inma. I have a couple just quick clarification questions. So when you're talking about these circularity indicators in iFishIENCi project and the zero waste indicator, could you consider these indicators as innovations in themselves? Is the use of these indicators intended to then, once they're qualified and kind of solidified, for aquaculture businesses to put those into practice?
Yeah, definitely. I think that the indicators for sustainability, for circularity, should be considered as an attribute of the new feed, for example. So if we think to commercialize final products, we can say that we are assessing the circularity of these products. And I think that it's quite interesting for the commercial and for future innovation.
And then the idea also is that if businesses are going to use these, they also need a certain type of policy uptake, I would think, some kind of common definition. Is efficiency or impact working on these kind of common circularity definitions?
Yeah, this is the final panel for today.
Oh, yeah. We'll have to, that's a little preview of the policy, obviously, and Martina is also going to talk about that. Okay, we'll go from home office in Norway to Aquabiotech in Malta. Danny, this is Bergen calling. Do you have a question for Inma?
Hi, I've got a question here from Olga. They ask, how does harvest costs differ from the extra protein produced in IMTA? So, for example, can IMTA cover its own costs?
I think that is probably not a question for
maybe not so much for yourself, Inma, but maybe a general question for the panel on maybe life cycle costing.
Daniel, do you have a good insight for that question?
Yeah. So the question, can you repeat the question, please?
Yes. Where did the question?
Sorry, Daniel. The question is, can IMTA cover its own costs? So does harvest costs differ for the extra protein produced? And does it get inflated for IMTA compared to a monoculture?
Yeah, the cost effectiveness analysis performed within the impact project has proved that the OPEX cost may increase due to the new elements that has to be installed, infrastructure, but new personal cost for the maintenance and the gathering and harvesting, and so on. The fact is that after all these OPEX costs that may increase the cost, we have a net profit due to the production of the new species that overcome the cost of the OPEX cost, and in the end we have a net profit value that shows that has a better performance for the IMTA than for the monoculture conditions.
Thanks, Daniel. Inma, I have a question, because you were mentioning the demo sites in the iFishIENCi project and trying to get all the output needed to start to qualify these circular principles. These different demo sites also have different ways of production too. And I would expect that that's a bit of a challenge for the circularity output. So can you maybe describe the different types of aquaculture setups that you're working with, and maybe some of the difficulties in kind of streamlining that into these circularity indicators?
Yes, it's definitely a challenge to provide a common circular indicator for every kind of aquaculture system. We are basically working for a system. This is a control environment where we have information from waste and waste valorization. This is something that is not possible in open system. But however, we are using feed in any case. So if we focus on the circularity in the feed and the feed manufacturing, we can provide circularity assessment for the whole industry. On the other hand, waste management is something only possible for closed system or RAS system.
Right. And then there's the open system in Greece, and then the closed system at Aquabiotech in Malta. And then is there a third site as well, or we're focusing on those two?
Focusing in those two in this step, but mainly on RAS system. Yeah.
Yeah, because then you can, it's only in the RAS system you can really get that more circular aspect. Danny, next question, please.
Thank you so much. So Inma, we've got a question here. Which industries have been identified by the iFishIENCi project that can be integrated into the zero waste indicator? I assume aside from the specific aquaculture industry.
Basically, at the first glance, pharmaceutical, cosmetic industry are key industries to collaborate with aquaculture sector. We are not focused on those industry in iFishIENCi as we are focused on aquaculture, but obviously there's an opportunity for cosmetics using algae or pharmaceutics uses.
Cosmetics does that mean that I'm going to be putting a sludge on my face?
Yeah.
No, as long as it gives that glow, then I'm all for it. No, I have a more serious question, and that's aquaculture doesn't occur in a vacuum because consumers have other choices of protein in the store. So do you know offhand, and any other panelists who want to weigh in on this? I mean, these circular principles also would be relevant for chicken production, pork production, beef. And how does aquaculture kind of, and these innovations pair up, or are they going in parallel, or there's a little bit of crosstalk with these food production systems as far as circular principles? I see Roberto's thinking really hard on this question.
Well, I think that there could be a link with other sectors, and not only our project, but also other projects are testing, for example, the reuse of sludge in agriculture. And that could be an example of involving other food production or linking to other food production starting from aquaculture.
Mm. But it's truly, I mean, the RAS system, the recirculating system, I mean, I don't know of any other agriculture systems that are so closed. So yeah, I think it's there's so much potential for aquaculture. And
yes, but for example, what we did with mortalities can apply also to open systems.
Yeah.
Because by drying them and reducing them into a kind of sanitized powder, then you can reuse them for this purpose.
Mm-hmm. Cool, great. Danny, next question, please.
I've got a question here, but I'm a little bit worried that the answer might contain spoilers for our next session. Do you think it will be easier to get licensing for aquaculture if you're doing IMTA instead of a more traditional aquaculture production? Do you think producers who jump on and follow this next wave are going to have an easier time from a regulatory or a licensing point of view?
Do you want to answer? Or
yeah, let's go for answer. And Inma, and then Frank can also weigh in.
I can answer that. From our experience, no, it actually is more difficult. The general process of licensing looks at single species. So when you add the complication of multiple species in the one area, it makes things more difficult to regulate and to assess. And we discovered that particularly within one of the pilots in the impact project, getting the IMTA license was quite a challenge.
Yeah, this is a really important issue here. I think it would be really good to go use that as a segue to our next section. Thank you, Inma. We're going to talk to you in a little bit, so don't go anywhere.